Good afternoon to all of you. Till now, we have discussed about the three major communication procedures which is used in embedded system. And in the last lecture, we have discussed about the USB protocol, USB communication procedure, rather, how communication take place by using the USB. And we have seen that the USBs are much more faster in comparison to the SPI, I2C, and QARP communication. Now, today we are going to study about the one more communication procedure or communication process, and that is RS2. So, first of all, what is RS232? How it is used? So, these are the things which we are going to discuss in the lecture. So, let's start. So, what is RS2? Officially, RS232 standard is called as TIA or TIA232, and it is defined as the interface between a DT and TCP devices. Means data transmission and data reception devices. The process of communication is rather very simple and similar, as it is also using the serial binary data interchange process. So RS232 is considered to be a very appropriate standard which is used in way back in 1990s, and still it is very much functional. This is because RS232 ensures that there is no conflict between the DT and DC devices by specifying. So RS232, by specifying certain parameters, resolves the conflict process or resolve the conflict issues. Now, we are going to study in detail about the different parameters, that is electrical specifications, mechanical specifications, functional specifications, and about the procedural specifications. So, before moving to the description part of RS232, some of the general features of RS232 should be considered or should be discussed. So here are the general specifications you can say about RS232. It is developed by the EIA, that is Electronics Industry Association or Telecommunication Industry Association. This is one of the oldest, most widely used serial communication standards. This standard is used in very early days of the communication between electronics components. It is used for communication between DT, that is transmitting device, that is maybe a computer, maybe a controller, and DCE, means the actual device from where the data is going to be transmitted. Means the data is generated and then data is transmitted. This stands for data terminal device, and DC stands for data communication device. So DT is the device which actually produce the data, and it is the device which तो यहाँ पे जो हम लोग बात कर रहे थे वो ये कर रहे थे कि डेटा जो है वो प्रोड्यूस होगा डेटा टर्मिनल डिवाइस पे, and then after the data is now transmitted to the other device through DC, and that is known as data communication device. The protocols which is used in RS232 are multiplex serial communication and asynchronous. Means the data is transmitted in both the directions at the same time. Data is transmitted serially, means data is transmitted bit by bit, and it requires no clock signal to transmit the data. Normally, the speed which is used in RS232 is up to 9600 bits per second, and as the length of the cable increases, the speed decreases. So naturally, it is very effective for the short communication, for distance communication. It is not very feasible. It is not very good for the long distance communication. लॉजिक लेवल्स की अगर बात करें तो लॉजिक लेवल्स रिसीवर के लिए जो है वो -3 से -25 वोल्ट का लॉजिक 1 होता है, +3 वोल्ट से लेकर के +25 जो है वो लॉजिक 0 होता है। अगर ट्रांसमीटर की बात करें तो लॉजिक लेवल जो है वो -5 वोल्ट से -15 वोल्ट तक लॉजिक 1 होता है, और +5 वोल्ट से +15 वोल्ट तक लॉजिक 0 लेवल दिया जाता है। तो RS232 के केस में रिसीवर और ट्रांसमीटर के लिए लॉजिक लेवल्स डिफाइंड हैं। अब इसकी थोड़ी और बात कर लेते हैं। मेनली अब हम उन प्रॉपर्टीज की बात करेंगे जिसकी चर्चा हम लोगों ने पहले की थी, जैसे इलेक्ट्रिकल कैरेक्टरिस्टिक्स। इलेक्ट्रिकल कैरेक्टरिस्टिक्स ऑफ RS232 की अगर बात करें तो इलेक्ट्रिकल कैरेक्टरिस्टिक्स RS232 के डिफाइन करती है वो स्पेसिफिकेशंस जो क्लोजली रिलेटेड होती हैं इसके वोल्टेज लेवल से, इसके लाइन इम्पीडेंसेस से और रेट ऑफ चेंज ऑफ सिग्नल लेवल से, कि कैसे वेरिएशंस हो रही है, कैसे चेंजेस हो रही हैं लॉजिक लेवल्स में। -12 वोल्ट से लेकर के +12 वोल्ट का जो वेरिएशन है, या यूं कह ले जो ये लेवल है, वो इसके लॉजिक 0 लॉजिक 1 लेवल को डिफाइन करता है। तो -12 वोल्ट को 1 लॉजिक लिया गया और +12 वोल्ट को लॉजिक 0 लिया। RS232 was defined way before TTL logic, and hence it is not expected that RS232 doesn't use the TTL specific 5 volt and current. अब अगर चूंकि अभी हम लोग used to हो चुके हैं कि 0 volt means logic 0 and 5 volt is considered to be a logic 1 level, but this is not the case in case of RS232 because RS232 are developed way before TTL. Generally, the TTL have the logic levels of 0 and logic levels of 1 corresponding to 0 volt and 5 volt. Here this is not the case. In this case, logic 0 is treated at +3 volt to +50, whereas logic 1 is defined at the range of -3 to -50. So typically, if one value has to be taken, that what is the exact range or exact value is defined the logic 0 and logic 1 in case of RS232, then logic 1 is at -12 volt and logic 0 is considered to be at +12 volt. All the above mentioned voltages are with respect to a common ground pin, and any voltage between -3 to +3 volt is considered to be an undefined logic state. So voltage between -3 to +3 volt is not defined in any of the logic states, or in 0 volt or in 12 volt. It is not considered in these two ways. Historically, logic 1 is referred to as a marking and logic 0 is referred as spacing. So historically, when the transmission of data takes place, logic 1 is referred as the marking signals and logic 0 is referred as spacing signals. It is used for spacing. So these are the electrical characteristics of RS. Now, if you talk about the mechanical specifications, the mechanical specifications of RS232 covers the mechanical interface of the standards. The RS232 standard specified a 25-pin D-type connector to support the full functionality of RS232. In the next slide, we are going to see that how it looks like, and it is known as DV25 connector. The DT device uses a female outer casing with the male pins, and the DC devices use a male outer casing with female pins. This is the characteristic feature of the male and female connectors, which is used in RS232 or DTE and DC. So this is a particular diagram of RS232 25-pin connector. In this diagram, you can easily see that the upper line is having 13 pins, and the lower line is containing 12 pins. And each of the pin has a role to play. Pin number 1 is used as a protective ground. Pin number 2 is used for transmitting data. Pin number 3 is used as a receiving data terminal. Pin number 4 is used to request to send signal. It is used for requesting a signal to be sent. Then comes the pin number 5, is used for a signal that is clear to send. Means the channel is now ready, means the path is now ready between terminal and transmitting and receiving devices. And now the data can be sent. Pin number 6 is used as a data set ready pin. Pin number 8 is used as DCD, the signal detected line. 9 and 10 is used for plus voltage, negative voltage, as the positive voltage, negative voltage sign. Pin number 11 is left assigned. Pin number 12 and 13 are DCD and CTS. So DCD and CTS are the secondary receive line detector and secondary clear to send signals. Primary is 4 and 5. Similarly, in the second line, pin number 14 is used as a secondary transmitted data line. Pin number 15 is used for transmitter signal timing purpose. Pin number 16 is secondary receive data pin. Pin number 17 is using the receiver signal element timing pin. Pin number 18 is for local loopback signals. And number 19 is for secondary request to send signal. So you can easily see here that two sets of pins are used. One set of pin is for primary and the other set of pin is for secondary data transmission and reception. So the second line is specifically states about the secondary data transmission and reception of the signals. Pin number 22 is the ring indicator. Pin number 23 is data signal rate is selecting pin. 24 is DT transmitter signal element timing. And pin number 25 is used for test for checking the connector whether it is functioning well or not. So this is a diagram of T25. Now you can divide these signals, these pins, into 4 major categories on the basis of their purpose. They are broadly divided into 4, or you can say 3 parts, that is data, control, and time. So if we talk about the transmitting and receiving data pin to DCE and from DCE, it comes under data signal type. If you talk about the different control signals which are used between transmitting and generating and before transmission, then there are requirements of different signals to indicate whether the DT and DC are ready for communication. So these signals, that is, such as request to send, clear to send, DC ready, DT ready, ring indicators, DCD, DT, DC, ready for receiving, remote loopback, local loopback. These comes under the category of control, because by using these control signals only, the actual data transmission takes place. Transmitter signal element timing from DT to DC. Again, this comes under control signals. Some signals are used for timing purpose. That when to send the signal, when to send the data, when it is going to be received by the receiving at the receiving end. So for this, two signals are used by DC devices, that is transmitter signal element timing from DC and receiver signal element timing from DC. Similarly for data, secondary transmitted data and secondary received data is used. And four more control signals are used by DC, such as secondary request to send, secondary clear to send, secondary receive line signal detectors. So these comes under the control signal category of RS232. As the electronic equipment and devices are getting smaller, electronic devices they do not have room for longer connector like DB, larger connector like DB25, and most common applications do not require all the 25 pins in the connector. Hence, there is a requirement of a smaller connector, and for that purpose, a reduced function 9-pin connector is used. So the DB28 connector is now replaced by DB9 connector, which you can easily see at the back of your PC or the sides of the laptop. These DB9 connectors are easily used. The 9-pin connector is called as D9, often wrongly as DB9, and it is a D-type CV miniature, sub-miniature connector. It also comes in the two categories, which DB25 comes, that is male and female. Two categories. It is rather the similar structure of D shape, so it is also called as D9 connector. So this is the diagram or the feature, having the features and as well as the diagram of DB9 male connector. So in DB9 male connector, you see that the first row has 5 pins and second row has 4 pins, which RS232 pin have total of 9 pins, 1, 2, 3, 4, 5, 6, 7, 8, 9 pins, and all these pins have different role to play while communication takes place. DT normally comes with a male connector, while DC comes with a female. However, that is not always true. Use the simple way below to confirm. There's a third pin and fifth pin of DB9 connector with a voltage. If you get a voltage of -3 to -15 volts, then it is a DT device. And if the voltage is on pin 2, then it is DC device. So you can easily check that whether the connector is of male type or female type by just measuring the voltage at pin number 3 and 5 and pin number 2. So these are the basic diagrams of male and female connectors. The numbering sequence is different in male and female connectors. And the sequence of signals is also changed, which you can easily differentiate when you see the male and female connectors. That in male connectors, the numbering from of pin is from left to right. It's 1, 2, 3, 4, 5. Starting from CD, then RXD, then TXD, then BTR, and then GMD. And if you look at the female codes, the numbering is from right to left. And There is a change in numbering of pin number 2 and 3 also. Here the pin number 2 is 2xd, whereas in the male connector the pin number 2 is RX. So both these pins are to change their role. Similarly, in the second row also, if you see, there is a reversal on and pin number 7 and 8 functionality. For male and female connectors. So these are the basic changes in the functionality. If we have to describe the functionality of all the pins, then pin number 1 is used for carrier detect. The signal is coming from DCE to DTE. Pin number 2 is receive data. The signal or this data, actually this is a data line, so this data comes from DCE. In number 3, that is TD, transmit data, and this data is goes to DCE, outgoing data to DCE. In number 4 is DTR, data terminal ready. So outgoing handshaking signal is used for handshaking purpose. In number 5 is ground pin, which is a common reference voltage. In number 6 is DSR, that is data set ready, that is used with incoming handshaking signal. In number 7 is RTS, request to send, that it is outgoing flow control signal. In number 8 is CTS, incoming flow control signal. In number 9 is an incoming signal to PCE, that is a ring connector. So all these 9 pins have a separate role to play. Then there is a data transmission. Then comes the procedural specification of RS232. That what are the procedural specifications of RS232? So there may be a chance that a question be asked in the examination. Short answer type, that what are the procedural specifications of RS232? So when we talk about the procedural specification of RS232, the procedural specification of RS232 is specified a sequence of operation that must be carried out when a DTA and DCE are connected. So what is the actual process when a communication takes place between DTA and DCE? How it is initialized, how it operates. So assume if a computer is connected to a modem. So naturally the computer is DTE and modem is DCE. And they both are connected through a RS232 interface. So in order to send data from computer to modem, there should be a procedure. There should be a principle on which the data communication takes place. When modem DCE is ready to receive, it will send a DCE ready signal. यानी जब मॉडेम रेडी होगा रिसीव करने के लिए सिग्नल, उस कंडीशन में वो एक सिग्नल सेंड करता है, दैट इज DCE, so that now modem is ready and it is ready to receive the data by sending a signal DCE. Then the computer DTE is ready to send the data, it sends a ready to send signal. Now when a computer has to send the data, so before sending the data, the computer sends a RTS signal that ready to send signal. The signal is ready to send. After detecting the RTS signal, the modem then sends a signal, that is CTS signal, which is nothing but a clear to send signal to indicate that now the data transmission can be initiated, can be started from the computer or the DT. Finally, the computer DT sends data on transmit data line to modem. So when all these signals play their role, finally the data is transmitted between the computer, between the microcontroller or laptop, or any device that is used for data transmission to the modem. So this is the actual procedure of data transmission in RS232. In the next slide, we will see a typical diagram where we see that how computer and modem be connected. And here a computer is nothing but a PC, which is a DTE device, and modem is the DCE device. And this image illustrates how they are connected and how the data transmission is performed. The computer and modem communicate with each other using RS232 interface, and the communication between the modem is established using telecommunication links. So the actual transmission, data communication transmission between the modem is established by using telecommunication links. So in this diagram, you see that between a computer, here it is a laptop, is connected to a modem through this RS232 cable, and this laptop acts as a DTE device and modem acts as a DCE device. So between modem and DTE, the communication is used here is RS232. And between the DCE and DCE, which is at the receiving end, modem at receiving end, there is another telecommunication procedure take place. And at the receiving end, you can use again RS232 between the receiving modem and the receiving computer or receiving laptop. So here at the receiver end, again RS232 communication. So this is the diagram which depicts or which shows the connectivity between this. So how RS232 actually works? In RS232, the data is transmitted serially in one direction over a single data line, because the two wires are used only, that is TX and RX line. So data is transmitted through RX line, sorry, TX line, and it is received by RX line at the modem. And the ground pin is used as the reference voltage signal. As it is an asynchronous type of communication, so a byte of data can be transmitted at any time. It needs no clock signal to synchronize it. The transmission of data only see whether the previous byte is completely sent or not. RS232 follows a synchronous communication protocol, so it does not require any clock signal to synchronize between the DTE and DC. Hence, it uses start-stop bit to inform the receiver when to check for data. So there are control signals which we have seen in the previous slides, that there are plenty of such signals used between the modem and the computer for checking the availability of transmitter and receiver components. There is a delay of certain time between the transmission of each bit. This delay is nothing but an inactive state, that is, a signal is set to logic 1 and then signal is goes to logic 0. So there is a change of, you can say, 24 volt. If it is changed from plus 12 volt to minus 12 volt, then there is a change of 24 volt between both the logics, that is from logic 1 to logic 0. So it takes some time for transmitting data. First, the transmitter, that is DT, sends a start bit to the receiver. So DT, first of all, sends a start bit to the receiver. Then DCE, after getting this signal, inform that the data transmission starts from the next bit. Now the DCE knows that the next bit is the actual data bit. The start bit is always 0, that is plus 12. And after sending the start bit, the actual data bit is of either in the range of 5 to 9 volts or some 9 bits. If you are using a parity bit, a maximum of 8 bits can be transmitted, because the maximum possibility is of 9 bits. So in that case, 8 plus 1, that is 9 bits, including the parity bit transmitted. And if parity isn't used, then total 9 data bits can be transmitted. After sending the data, after the data is transmitted, the transmitter sends the stop bits. Now it signifies that the data is transmitted. So how this process is carried out? It is carried out by sending 1 or 2 or 1.5 bits for indicating that now this operation is going to be completed. The following image shows the frame format of the RS232. So here, how it is 1.5 bits. The question comes that how a 1.5 bit is going to be transmitted. So here, the concept of 1.5 bits is nothing but it is the bit length is of 1.5 clock cycle. So either logic 1 is of 1.5 life cycle, or it is 0 of 1.5 life cycle, which indicates 1.5. So this is the format of data which is sent between DT and DC using RS232. So in this format, you see that the first bit is naturally the start bit, that is 0, that is logic 0. Then after, it consists of 8-bit data from B0 to B7. So it has 8 bit of data bits. After the data bits, that is B7, a parity bit is introduced. And after the parity bit, 2 stop bits are used, S1 and S2. So that the data transmission process is now complete. So an example is given below, which shows a data transmission of bits. And this pattern is written here, that is 0 1 0 0 0 0 0 1. So first the data bits are 0 1 0 0 0 0 1, and parity bit is 1, and then after a 1 stop bit is used for this particular example. So all these things shows about the RS232. So RS232 is a very first communication procedure between transmitter and receiver It's a wired system. It is used for serial communication. Now, the advanced version of RS232, which have some more features, is RS422 and 485. RS422 and RS485 are the common names for two serial communication standards. The standards again defined by the TIA or TIA, and they are known as TIA 422 or TIA 422 and EIA 485 or TIA 485. And these two standards are used for communicating digital information over twisted pair wire between transmitters and receivers. So they are naturally the advanced version, you can say, of 2.3. So what are the features of RS422? RS422, as we discussed, it is a standard, the standard given by Electronic Industries Association, which is of Electronic Industries. It gives the standard name as RS422, and which is used for digital signaling circuits. The main function or main purpose behind RS422 is to replace older version of RS232C with a standard which is more quick, means much higher speed, and not only speed, but it also has immunity from noise. And the data can be transferred securely up to a very long distance, which is not possible in case of RS232. RS422 systems can transmit data at rates as high as 10 megabits per second. तो RS422 की बात अगर करें हम लोग, तो इसमें डेटा ट्रांसमिशन जो है वो 10 Mbps तक हो सकता है, और जो रेंज है, जो लेंथ है केबल की, वो 1500 मीटर तक हो सकती है। हालांकि उस वक्त आपको रेट्स 10 Mbps की नहीं, उससे थोड़ी कम मिलेगी। RS422 और RS423 काफी कुछ सेम है, सेम सिग्नलिंग सिस्टम को यूज करते हैं। थोड़ा सा वायरिंग अरेंजमेंट जो है वो 422 और 423 में अलग है, तो इसको डिफरेंशिएट करता है। अदरवाइज 422 एंड 423 आर द have a similar functional procedure. Devices can be up to 4,000 feet or 1,220 meters apart before repeaters are required. यानी कि सिग्नलिंग अगर हम लोग कर रहे हैं 422 को यूज करके, तो 4,000 फीट या 1,220 मीटर तक हमें किसी रिपीटर की जरूरत नहीं होती। हमारा डेटा जो है वो एज इट इज इंटैक्ट रहता है, इजीली ट्रांसफर्ड होता है एक जगह से दूसरी जगह तक, और वो भी कंसिडरेबल स्पीड पर। RS422 जो है वो 10 रिसीवर्स को एक साथ डेटा सेंड कर सकता है, और 485 के केस में यह संख्या बढ़ के 32 हो जाती है, 32 हो जाती है। जबकि RS232 में हमने देखा था कि वो सिंगल डिवाइस को ही कनेक्ट करता है। RS422 और 485 की बात करें तो ये मैक्सिमम स्पीड इसकी जो है ऑपरेटेबल स्पीड वो 10 Mbps की होती है। चाहे 422 हो या 485 हो, both the system utilize balance in outputs and differential inputs. तो बैलेंस आउटपुट और डिफरेंशियल इनपुट्स होने की वजह से नॉइस इम्यूनिटी जो है वो एनहांस हो जाती है, बढ़ जाती है। So it has a better noise immunity if you compare it with the single-ended system such as RS232, जहाँ पे हम लोग सिंगल डिवाइस कम्युनिकेट कर पा रहे थे, और फिर भी वहाँ पे एक पॉसिबिलिटी थी कि डेटा may be corrupt, data may have lost, and the noise can affect the data. So naturally, RS422 and 485 have better characteristics in comparison to RS232. This results in the ability to operate over longer distance at higher bit rates than links using RS232. तो ये वो कारण है जिनकी वजह से RS422 ने या RS485 ने RS232 को रिप्लेस किया और उसकी जगह दूसरे कम्युनिकेशन को यूज कराया गया, जैसे 422 और 485। तो अगर सिर्फ 422 की कैरेक्टरिस्टिक्स की बात करें, इसकी वो कौन कौन सी कैरेक्टरिस्टिक फीचर्स हैं तो इसको इतना यूजेबल बनाती हैं, तो RS422's capability make it a good choice for extending the distance and the speed of point to point. तो RS422 की ये कैपेबिलिटी है जिसने डिस्टेंस और स्पीड को बढ़ाया पॉइंट टू पॉइंट कनेक्शन में, सिर्फ डिस्टेंस को बढ़ाया बिटवीन द डिवाइसेस, बल्कि उनके बीच के स्पीड ऑफ ऑपरेशन को भी बढ़ाया। वो सिचुएशंस जिसमें डेटा को लॉन्ग डिस्टेंस तक कैरी कराना हो, और ना सिर्फ कैरी कराना हो बल्कि उनको इम्यूनिटी प्रूफ भी, यानी इम्यून प्रूफ बनाना हो, उनमें इम्यूनिटी रहे, किसी इलेक्ट्रिकल नॉइस के थ्रू उनमें वेरिएशंस ना हो, बिट्स में चेंज ना हो, उस कंडीशन में भी 422 और 485 232 से काफी कैपेबल नजर आए। RS422 provides a higher reliability replacement for standards such as RS232. तो RS422 ने हायर रिलायबिलिटी रिप्लेसमेंट की तरफ वर्क किया RS232 के जगह पे। तो RS232 में रिलायबिलिटी उतनी सही नहीं, उतनी कारगर नहीं, डेटा उतना रिलायबल नहीं था, क्योंकि लॉन्ग डिस्टेंस पे डेटा की इम्यूनिटी अफेक्ट होती थी। अगर वो इलेक्ट्रिकली नॉइज जनरेटेड इन्वायरमेंट से हो करके वो वायर को अगर हम ले जा रहे हैं लैपटॉप और मॉडम के बीच में, अगर देयर इज अ पॉसिबिलिटी ऑफ EMI, इलेक्ट्रोमैग्नेटिक इंडक्शन, then there is a chance of data corruption. उसको पूरी तरह से एलिमिनेट किया गया RS422 और 485। RS422 also makes it possible to create point to multi point connection. तो एक ट्रांसमीटर कई सारे रिसीवर्स को गाइड कर सकता है, उनको डेटा दे सकता है। पहले बात की RS422 के केस में 10, 485 के केस में तो 32 मल्टी पॉइंट कनेक्शंस को ड्राइव किया जा सकता है। In a point to multi-point arrangement, the node originating the data can broadcast data to several vector points. तो इससे एक ट्रांसमिटिंग एंड से आप कई सारे स्लेव नोड्स को डेटा एक साथ सेंड कर सकते हैं, ट्रांसमिट कर सकते हैं। सेम डेटा कई नोड्स पे एक साथ सेंड किए जा सकते हैं। ये फीचर RS232 में है। हालांकि अगर आपको डेटा रिसीव करना हो सारे ही नोड से, सारे स्लेव नोड से, तो फिर आपको हर एक स्लेव पे एक 485 डिवाइस की जरूरत पड़ेगी, क्योंकि अगेन फिर वहां आपको सेंडर की जरूरत पड़ेगी। RS485 जो है वो 2 और 4 वायर यानी कि 2 and 4 वायर नेटवर्क को यूज करता है। तो ये एक डायग्राम है जिससे काफी चीजें क्लियर होंगी कि कैसे कनेक्शंस हो रहे हैं। यहाँ अगर आप देखें तो एक पीसी है, पीसी के सीपीयू से यूएसबी पोर्ट के थ्रू 422 कन्वर्टर्स यूज में कनेक्ट किए गए हैं। और 422 जो है इसको लॉन्ग डिस्टेंस हाई स्पीड ट्रांसमिशन में इजीली कन्वर्ट करता है। एट द रिसीवर अगेन जो फील्ड डिवाइस है, जो कहीं फील्ड में है जहाँ हमें डेटा भेजना है, वहां पे 422 उस डेटा को रिसीव करता है। फिर RS232 के जरिए वो सिग्नल को फील्ड डिवाइस तक पहुंचाता है। फील्ड डिवाइस फिर उस सिग्नल को जिस भी जगह पे यूज करना है, जो भी एप्लीकेशन है, उस डेटा को इजीली वहां पे यूज करता है। तो अगर हमको किसी क्लीन एरिया में बैठ करके जहाँ पे नॉइज प्रूफ है, जहाँ कम नॉइज है, वहां से डेटा सेंड करना हो, किसी ऐसे एरिया में जो बहुत नॉइजी एरिया है, जहाँ पे डेटा सेंड किया जाना आसान नहीं है RS232 यूज करके, तो हम फिर 422 की सहायता लेते हैं। 422 के थ्रू डेटा ट्रांसमिट करते हैं। तो दो फीचर्स हमको वहाँ पे मिल जाते हैं, दो फैसिलिटी मिल जाती है। एक फैसिलिटी तो मिल जाती है कि हमारा डेटा सुरक्षित रहता है लॉन्ग डिस्टेंस कम्युनिकेशन, और दूसरा स्पीड ऑफ ट्रांसमिशन जो है वो एनहांस, यानी डेटा की जो ट्रांसमिशन स्पीड है वो बढ़ता है। तो ये दोनों ही फीचर्स अगर हम देखें तो RS232 के साथ पॉसिबल नहीं। तो आज हम लोगों ने इतनी बात की। नेक्स्ट लेक्चर में हम लोग 485 के बारे में डिटेल बात करेंगे कि 485 की फंक्शनैलिटी क्या है, कैसे काम करता है, क्या डिफरेंस है 485 का 422 से, 232 से, कैसे उसने जो है रिवॉल्यूशनाइज किया, चेंज किया कम्युनिकेशन के प्रोसेस को एम्बेडेड सिस्टम के केस में। बात करेंगे कि हम किसी एम्बेडेड सिस्टम के लिए डिजाइन करने जा रहे हैं, so what is the feasible solution for us? Whether we go for RS232, 222, or 285, which is suitable for our project. But certainly we have the knowledge, we should have the understanding of communication process. This entire unit, if you see, is based on the communication protocols, communication procedures, which is used in embedded as well as larger system where the multi processors are used. Embedded system of a very strategic purpose, and constraint purposes, uses which of the communication is deciding after having the broad knowledge of all these protocols. तो उनमें से आज कुछ प्रोटोकॉल्स की बात हम लोगों ने की। बेसिकली आज हम लोगों ने जो बात की वो RS232 के बारे में की, RS422 के बारे में की, RS232 कैसे काम करता है, क्या उसके फीचर्स हैं, क्या उसके डेटा फॉर्मेट है, कैसे वो अपने प्रोसेस को इनिशिएट करता है, किस तरह से BT और TC के बीच में कम्युनिकेशन होता है, कितने डिस्टेंस तक हो सकता है, उसमें जो दिक्कतें आ रही थी उन दिक्कतों को किस तरह से आगे RS422 में रिमूव किया गया, RS422 का इस्तेमाल कहाँ पे किया गया, RS422 ने फिर किस तरह से जो है वो एडवांसमेंट की, इसके बारे में आज हम लोगों ने विस्तार से बात की। नेक्स्ट लेक्चर में जब हम लोग आएंगे तो RS485 के बारे में बात करेंगे। By using RS485, how the communication between transmitting and communicating devices take place, क्या उसके फायदे हैं, इन सारी बात को हम लोग नेक्स्ट लेक्चर में डिस्कस करेंगे। तो आज का लेक्चर यहाँ पे एंड करते हैं। थैंक्स टू ऑल।